Hello guys, so this is for those of you guys who I think period 5, I think we never got to the, or I don't remember, I'm sorry, maybe it was period 1, we never did the notes for the left side of your flip book on the back of the white page. We did I did a video on law of cosines, but I never did a law on special right triangles, so I'm going to do that now for you. So obviously over here you already wrote a bunch of stuff in my previous video, so I'm going to leave that blank. And oopsies. Okay. Okay, so special right triangles. You can up to you. You can draw this first and then watch the video, or you could just watch the video, relax, get back, and then write the notes later. So there's two types of special right triangles, which are very important to know in higher math, especially in the SATs. Special right triangles come out a lot. Special right triangles are right triangles. There's two types, but this one has a it's a 45 45 90 triangle. Okay, so we call it, that's what we call it. We call them 45 45 90 triangles. Okay, that means it's a right triangle, but two of the angles are the same. We could call those base angles. If those base angles are the same, then we know that those sides are the same. So this is an isosceles right triangle. Okay, so we have, well, obviously, let's say this side is x. If this leg is x, the other leg has to be x because it's an isosceles triangle. How much is this side going to be? Okay, well, for those of you guys who like to see proof of things, I'm going to just do a little proof right here. According to the Pythagorean theorem, this side squared plus the other side squared has to equal the hypotenuse squared. That means 2x squared has to equal hypotenuse squared. And if I want to know what one hypotenuse is, alright, so easiest is if they give us the short leg. Now if the short leg, this triangle shifted, the short leg is over here across in the small angle. If they gave us this as 5, then right away I know the hypotenuse is double the 5, so it's 10. And the long leg is whatever the short leg was times rad 3. Okay? If this is 6, then this is 12 here, and this is 6 rad 3. Okay? What if they give us the short leg, but it looks ugly? Like, what if they told us that this is 6 rad 3? Then to get to the hypotenuse, you double that. So that times 2 would be, I don't like that. So to multiply that by 2, it's just going to be, well, 6 rad 3 times 2. Well, to multiply the non-radicals together, we're going to have 12 rad 3. To get to the long leg, don't use the hypotenuse. Use the original OG short leg, and you're going to multiply that thing by what? Multiply it by rad 3. So what's rad 3 times rad 3? 3, because it's radical 9, and the square root of 9 is 3. So 3 times 6, this whole thing's going to be 18. Okay, so we have 6 rad 3 here, 18 here, and 12 rad 3 here. That's a good example. Actually, I would go ahead and record that one if I were you. I don't know. Maybe you could take your pick later. Okay, what else? What else? What else? I think I'm getting sick. What if they give you the hypotenuse? They told you this is 10. Well, go back to your home base. The best is when we know the short leg. So from the hypotenuse to home base is just half, right? Since the hypotenuse was double. So that's going to be obviously 5. And then get to the long leg, it's whatever the short leg was times radical 3, so 5 rad 3. That's easy. If this was 16, then the short leg is 8, and the long leg is 8 rad 3. Okay, now we figured out what to do if they give us the hypotenuse. We talked about what to do if they give you the short leg, which is the easiest. Oops, what if they give you the long leg? Okay, so what if they told you that this was 10 rad 3? Well, to always go back to your short leg, your home base. Well, to get from the long leg to the short leg, it's shorter. How much shorter? Well, we had to multiply by radical 3 to get to the long leg, so you have to divide by radical 3 to get back to the short leg. Well, if you have 10 radical 3 divided by radical 3, those radical 3s are going to cancel, you know? 10 radical 3 divided by rad 3 is going to cancel. So we're going to have just 10. So this is 10, which makes sense because if this was 10, you multiply by rad 3, you would have gotten 10 rad 3, right? When we go this way. Okay, so then this hypotenuse is double the 10, which is 20. That's nice because this was already kind of nice. It had a radical 3 in there, but what if it was not there? What if they just told us this was 6? To go back to the short leg, what do I have to do? It's 6. I have to make it shorter by dividing by rad 3. So you see why we have to divide by rad 3 to go back to the shorter leg. But what's wrong with this? We just don't like to have the radicals in the denominator. So we have to rationalize the denominator by multiplying by 1. Well, rad 3 over rad 3, which is 1. This is going to simplify to 6 radical 3 over rad 3 times rad 3 is 3. Oops. Okay, and then 6 divided by 3 reduces to 2, so my final answer here is going to be 2 rad 3 right here. And if that's 2 rad 3, then my hypotenuse is going to be double that. It's going to be 4 rad 3. Maybe that's a good one to do. I'm really tired, so we're going to stop here. Have a good night. Study. We've done all our new learning. No, we haven't. We have one more lesson to go, and then we'll be done with the unit. Bye. Want to say goodbye?
Bye.
Who is that?